Okay, so we've got our gems logically moving around, but we need to make them actually visually move around within the game itself. So to do that, we're going to need to assign a speed for the gems to move. Now, this is something we don't want to add individually to the gems themselves because we don't want each one of these having a different move speed. So what we're going to do is on the board, we're going to store how fast the gem should move. So let's go to our board script. If we go up to the top, we're going to create a public float value that we're going to call gem speed, like so. And then back in our gem itself, right up the top up here, we've got our update loop, which is handling our movement press at the moment. And right above that, I'm going to type in here, we want to make our objects move. So we're going to say our transform dot position of our gem should be equal to a vector2 dot lerp. So what is lerp? Lerp is something called linear interpolation. And if I go in here, I'm going to just create a new little paint file here. Linear interpolation is basically a way to make things move quickly between 2 points. So basically what it does, it'll say, I want to move a certain amount or a certain percentage between different values. So let's just imagine it's going to move halfway. So basically what will happen on each frame of our game, it'll say, okay, I'm starting here and that's where I want to go to. I want to cover half the different distance every time. So we're going to say here, okay, let's move to half the distance, that's here. So then on the next frame, it'll go, okay, I want to move half the distance again. So it'll move to here. And then it'll go half the distance again, it'll move to here. And half the distance and it'll move to here. And so on until it gets smaller and smaller and smaller. But basically what this does is you can see it creates a big massive jump at the start and then slows down as it gets closer. It basically creates a way of creating a smooth movement that looks like it jumps really fast and then slows down as it gets into place. So we use that as a way to make things move around nicely. So here we're going to say our transform position is equal to vector2.lerp, and then we need to tell it a few things. We need to tell it the point we want to start our lerp from, and that's wherever our transform.position currently is. Then we need to tell it where we want to go to, and where we want to go to is whatever our position index is. So whatever position we are setting our gem to be. So we're going to say move towards the position index, and then finally we have to tell it how fast we want that to happen, and we want to use the gem speed that we set on the board. So we're going to say board dot gem speed, and we're going to multiply that by something called time dot delta time. So time dot delta time, if you haven't encountered it before, is basically how long your update takes to happen. So if you have a game running at 60 frames a second, that means update will be called 60 times every second, and that means time dot delta time will basically be 1/60th of a second, so 1 divided by 60. And the reason you do this is so that your game stays consistent across different frame rates. So if you say you have something that is supposed to move one unit in 1 second. If you say, okay, well, if I wanted to move 1 unit in 1 second and I have 60 frames a second, you could just say, hey, make this move at 1 divided by 60 every frame. But then what happens with a player who only is running the game at 30 frames a second? If they're moving at 1/60th every frame, then basically in their 30 frame per second game, an object will only move half the distance, so it would only get to 0.5 of its distance that you want to go. So instead what you'll say is move at 1 multiplied by time dot delta time, so that in a 60 frame per second game it'll move 1/60th of the amount every frame, but in a 30 frame per second game it'll move 1/30th of a frame of the distance in every frame. But basically what will happen is on all those different computers running at different frame rates, they'll all get it so that after 1 second your item will move 1 unit. So it's basically a way of keeping everything consistent across different frame rates. So we do that so that our gem speed is always the same gem speed no matter who's running the game. Okay, so let's save this. Let's go back into Unity and let's see this in action. So if I go ahead and play now, and if I swap two of these around, we should get that happening, but it's not happening. Why is that not happening? I did actually save it, didn't I? 3, 5. So the position index is changing. Oh, haha! Because I didn't actually set a value on the gem speed of the board. I'm going to set this to be 7. And let's try this again. And there we go. So perfect. Now they're swapping. I just hadn't. It's hard for anything to move when it's trying to move multiplied by 0. So now you can see we can swap these gems, and we can keep swapping them all around, and they're moving to the correct position on the board. So perfect. We now have our gems moving around the way we want it to. Now, one thing about LARP is it will actually keep trying to move these things forever. So even though it looks like they're right in position, if I swipe this down, you'll see its position slowly gets down to 0, and it's actually handling numbers really, really low at this point. So we don't want it to keep doing that forever. So what we're going to do is, in here, we're going to say if our vector2 dot distance between our transform dot position and our position index, so if the difference between those is greater than 0.1f, actually we'll say 0.01, if it's greater than that, then make it LARP between those positions. But otherwise, we're going to say just set the transform dot position to be equal to the position index. Actually, that's giving us a bit of an error because it's trying to convert an int value into a float vector tree. So we're just going to say is equal to a new vector tree of position index dot x and position index dot y, and then 0. Okay, so perfect. We've now got our gems moving into position, and we're going to make sure as well when this happens that the board has the gem stored at the correct place. And the reason we're doing this is so that a little bit later, when we start making gems fall down into positions automatically, and not just when we do a swipe, we want to make sure that each one of those is storing its position correctly. So we're going to say here on our board, all our gems position index dot x and position index dot y. So the gem at the position we should be at is equal to this. So we're making sure it's definitely set to be this one. Okay, so let's just save this, and we'll go back in here, and now that this will be running, we'll be able to swipe these around. You'll see that it will snap into the correct positions now. So if I just move a few of these around here, although visually it doesn't really look too much different to us, let's say I just move this one here, you'll see now it no longer has the 4.0000. If I move it, you'll see, there we go, it just eventually snaps to the correct point. So perfect, we now have our objects moving around the way we want.